So now today we need to talk about work, energy, and power. So now I believe we have all understood what we call the dimensions, the basic topics and fixes, like all those units, the fundamental quantities, fundamental units. So we don't need to go back to that. So now today we want to talk about the work, energy, and power, and more precisely I will talk about work today. So now next I can talk about maybe in our next class I can talk about the energy and power. So now work. So different people have different concepts of work. Hence, the person may say I go to work, and that person may say I work in the school farm. Yes, we can say we can use work in so many ways. Some people can say, okay, I went to work, I go to work every day, I work on so things. So now, I want to mention works in such and such way. So now, in everyday life, the term work is applied to any form of activities that requires the exertion of physical or mental effort in physics or in mechanics. However, the term is used in a very specific sense, in a very specific sense. Work is said to be done whenever a force is applied to cause a body to move. So this is the major concept or the major things you should know about work. Work works with two things: force and distance. Whenever you want to, or a work is said to be done whenever a force is applied with a distance. So if you move without applying force, no work is done. And if you apply force without moving, no work is done. So for you to have said to work, or for you to have done a particular work, two things are involved. You must apply force, then you move to apply a distance. So now, a work is said to be done whenever a force is applied to cause a body to move. When you push a certain distance, when you push a certain distance, you are said to do work to a certain distance. Rather, like when you push a car from one point to another, you apply the force by pushing, then you move the car from one point to another. So in this case, you have done a work. So work, when no movement takes place after you have applied a force to a body, no work is done. So now this is all about work. This is all about work. So this is what we talk whenever we want to talk about work. This is work. So you should understand that work goes in two ways. We have force, then we have distance. So whenever a work is said to be done whenever a force is applied to a distance. So this is definition for work. If you lift a bag of palm kernels from the ground onto your head and carry the load standing on same spot even several hours, you have only done work by lifting the load from the ground to your head. So now just imagine you carry a bag of palm kernels from the ground to head, then you stand there for several hours. You stood for several hours. Just imagine that. So I know some of you will be saying that, okay, you have done a particular no, the only work you have done is that you have moved the bag of palm kernels from the ground to your head, because you applied a force by moving it, then a distance from the ground to your head. But you standing on that spot for several hours, you have not done any work. So that's just it. Work is said to be done whenever a force moves its point of application in the direction. So that's just about work. So here we have force is got work is equal to force multiplied by distance or displacement. So then work is equal to Fs. That S is denoting distance or displacement. So and the unit for force is either joules or Newton meter. So now things we should know. Now we should understand work done in a force field. So we introduced the idea of force field. We also noted that the Earth's gravitational field was an example of what? Of force field. In that gravitational field, there's always a force pulling a point towards what? The Earth's centers. So now we define force in a way of acceleration due to gravity, since it's always acts downward. Yes, whenever we are talking about the acceleration due to gravity, or talking about the particular weight is always act downward. So you understand. So now, so where are we? So its force always acts downwards now, and hence a weight, that is the force, is equal to mass times acceleration due to gravity. That is weight. That's weight as well. So whenever a weight is acted on a body, it always acts downward. So hence the weight or the force is equal to mg, mass times acceleration due to gravity. While the distance changes to height, yes, the distance, since we are not talking about the distance from one point to another online, since we are talking about the vertical, whenever you lift what's it called, a load, you lift it vertically upward. So hence then height is used instead of what? Instead of distance. So now, why the distance changes to height? Since we have object, since the object may be lifted vertically upward. Hence, weight is equal to mg. So weight is equal to mg will act downward, and distance will be defined in terms of what? In terms of height. So now we have force is equal to force times distance, as we said earlier. So force is equal to the force, weight is work done is equal to the force. We change this to what? Mg. Then the distance to h. So in this case, whenever we are talking about we want to define work in a force field or in a gravitational force field, so we talk about the work will change. We change this to what? To mgh, mass multiplied by acceleration due to gravity. It has a constant value, which is equal to 10 meter per second square, and multiplied by the height. So good. So now you should also know that work can be in direction, either vertical or horizontal. Yes, we can solve work in two ways. We can solve it in a direction, in two directions, either vertical or horizontal. Yes, let's look at the vertical aspect. If a load is being changed or is being lifted vertically, and a weight acts on it in a specified angle, yes, we will have an angle through the distance. So then the work is said to be done in that particular angle. Therefore, work done is equal to Fs sine theta. That is the force multiplied by the distance or displacement sine the specified angle, or mg sine theta. So now, horizontal aspect, we talk about the work in an horizontal aspect, rather. So it's if a load is being dragged, you understand, is being dragged or lifted, or is being dragged rather horizontally in a specified angle, the work done is said to be done in that particular angle. So the work done is equal to Fs cos theta or mg cos theta. Now look at this example. A boy of mass 50 kg runs up a set of steps of total height of 3.0 meter. Find the work done against gravity. So solution, here we have our parameters. Here we have mass to be 50 kg, we have acceleration due to gravity to be 10 meter per second squared, then we have the height to be 3.0 meter. So then we have said that our work done is equal to mgh, that is mass times acceleration due to gravity multiplied by height. 50 times 3 times 10, that's 1500 joules. So don't forget the unit. The unit is very, very important in physics whenever you are solving physics, please. So, and please don't forget to share, like, and subscribe. Good day. So look at this perfect example. A man holds a child on his shoulders while watching a football match. How much work has he done if the game lasts for 2 hours? Look at this beautiful example. So a man holds a child on his shoulders while watching a football match. How much work has he done if the game lasts for 2 hours? So this is one of the perfect examples. As you can see, this man, he only holds the child on a particular spot. So definitely he applied the force by holding a child's hand. But does he move, or did he move the child from one point to another? No, he stand on a spot for several hours. So in this case, he has not done any work. So the work done he has done is zero. So work done in this particular, or if you are to answer this particular questions, the answer is 0, because he has not done any work. So look at this perfect example. You might be asked in your upcoming exams like NECO or any exams. So he has done no work. This is one of the beautiful examples. So a man holds a child on his shoulders while watching a football match. How much work has he done if the game lasts for 2 hours? Even if he holds the child for 24 hours without moving from one point to another, he has not done any work. So good day.